So let's begin on our first problem. This is target number 6. We have the number 2021 has the property that all digits that are 0 are immediately adjacent to two non-zero digits. The number 438 also has this property because there are no digits that are 0. How many 5-digit positive whole numbers have this property? So we see that in the number 2021, there's going to be in between two non-zero digits is a 0, and so that satisfies this property. And then 438 also satisfies property because none of the digits are zeros, so every digit next to each other will have a non-zero digit in between. So when we're generalizing this to 5 digits, we need to see whether or not it contains a 0 or it doesn't. If it doesn't, it's very easy. But if it does, we need to consider a couple cases. So let's draw like 5 slots that represent the digits of the 5 numbers. Let's count the easy case first. If no digits are 0, then that's very easy because the first digit clearly can't be 0. There are 9 possible digits here. And then the rest of them can't be 0 either. And each choice of digits are independent of each other. So there are 9 possibilities for each case, each digit here for this case. So we have 9 to the 5th. No digits are 0. And this is case 1. But now we need to introduce some cases. More nuanced cases, a little bit more complex, that's when we add a 0 in. And so let's kind of experiment a little. So we have our little 5 digits again. We see that if we place a 0 either here or here, there's nothing coming after it. So that means that when the 0 is placed at the ends, it's only adjacent to 1 digit. We don't want that because that doesn't satisfy the property. We need to have 2 non-zero digits on the outside with a 0 in between. And so we can't have these cases. So when we're adding 1 0, actually 3 possibilities here. You have a 0 here, a 0 here, and a 0 here. Because then you'll have, in this first case, obviously the first digit, leftmost digit, is non-zero. It has to be, or else it's not a 5-digit number. And then here we need this digit, the right digit, to be non-zero as well. So each of these have 9 choices. In the same logic, these all have 9 choices, and these all have 9 choices. And so in the add 1 0 case, there is 3 times 9 to the 4th cases. Each one has 9 to the 4th. There are 3 possible cases for this possible case. So we have 3 times 9 to the 4th cases total. And then lastly, add 2 zeros. You can't forget this one because that's also legal. That's also, we can also do that. We can't do this in the same reason we can't do this or this or this, because we can't have any zeros in the extreme ends. And similarly, we can't have it on this side either, the extreme ends again. So the only way we can do it, since the zeros can't be consecutive, because that would violate the first property again, is to have them alternating in between, like this. That's the only case. Same logic. This gives us 9 cubed cases. And add these together. You can just use a calculator to get this easily. And you get 79461 possibilities. There, just write that down.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.